Okay, here we go. I'm gonna try to do these. I don't know if I can. I recommend if you get stuck, watch this and then just watch it until you need it and then pause it and try to finish and see how you do. I think we already did the derivative in class, but I don't have it. So I'll do it your guys' way now. Let's see. I know that squared is, I'm gonna go up here because I don't have much room. X minus 3 squared is x squared minus 6x plus 9. Multiply that by x minus 2, that'd be x to the third minus 6x squared plus 9x minus 2x squared plus 12x minus 18. See, x to the third minus 8x squared plus 21x minus 18. So the derivative, look how that's coming up, 3x squared minus 16x plus 21. Yeah, I remember that now. And then set that equal to 0 so we can factor it. It was 3x, x, 9, and 7. So both negative. So x equals 7/3 and x equals 3. That's where my slope is 0. So I'll set up my little number line here. 7/3, what's that? 2 1/3, so that's below 3. So here's 7/3, here's 3. I'm just going to make myself a little note. That's like 2.333. So over here, I don't know, pick 0, plug in 0 to my derivative, and I get 21, so that's positive. In the middle of 2.333 and 3, that sucks. 2.5. Hey, it's a parabola, so it's going to be negative and positive. I have a feeling. Plug in 4 squared, 16, 48, minus 64 plus 21, 48, 6, yeah, it's positive. I'm right. So there we go, we got that. So our slope goes from positive to negative and then negative to positive. So there we go. We got some maxes and mins here. Oh, we should have also checked. Does that have endpoints? Nah, derivatives all, or domains all real numbers. Will the derivative ever not exist? No, that'll always exist. Okay, so those were our only 2 critical points. So now we got it. Local max at 7/3. And local min at 3. I guess we can get the other ones. Well, 3 is easy. Plug 3 into the original, you're going to get 0. That's nice. Plug 7/3 into the original. Not so fun. You guys can plug and chug. I don't want to waste YouTube bandwidth sitting there plugging in 7/3 and doing fractions to get the answer. If you really want to know, you can do it tomorrow or something. But that's it. So you'd be done. Quiz, though, might ask for also, like this one. Might have to do 2 of those on the quiz, so I should have told you to do all of those for that thing, but that's okay. I didn't. So let's just do it on this one. Because this is the harder one anyway, since it's got the multiplication and the square root. Hey, first thing's extrema, so first thing we need to do is the derivative of that. Well, if you're sitting there thinking, I have no idea how to do the derivative of that, you should probably rewrite it as x times 4 minus x squared to the 1/2 power. And then do not bring that 1/2 power down and multiply it by the x. And
What?
don't bring that 1/2 power down, multiply by the x, and then just subtract 1 from that. It's product rule. So you have to do the product rule.
Oh, okay, yeah. Very interesting.
Yeah. I guess I can take a break to talk to Adrian, even though I'm trying to indicate to him that I'm busy. Okay, I just put the answer for the first one on there. So now, here are the answers for the two I just gave you. So there's that. Derivative of that would be what? X squared minus 4. And then second derivative, 2x. Sorry. Let's see, so if we're doing extrema, where the slope is 0, where the slope doesn't exist, that'll always exist though, and then endpoints, but there are none, so add 4 and then square root it, so x equals plus or minus 2, that's where the slope is 0. So I'd like to a little note that this is my first derivative, negative 2, 2, see, plug in negative 3, 9, minus 4 is positive, plug in 0, negative, plug in 3, it's positive, up, down, up. So, looks like local max at negative 2, let's see, this is easy to plug in negative 2 for x, so do what, negative 8 thirds, and plus 8 plus 2, yeah, so 10, 22 thirds, local min there, let's see, positive 2, that's just going to make that 8 thirds. Oh, that's going to make that minus 8. So 8 thirds minus 8 plus 2, so 8 thirds minus 6. So negative 10 thirds. There's min and max. What else did you have to? Oh, point of inflection. Second derivative equal to 0, so x equals 0. So your second derivative, x equals 0. So the only place it changes signs. See, to the left of that, it's going to be negative. To the right, it's going to be positive. So the point of inflection is at 0. Actually, you can put the exact point. Sorry, I'm tired. I just woke up. Point of inflection is 0, 2. Use the x coordinate would be nice. So then I think, what's that? Increasing and decreasing, all that stuff. So increasing, I don't really feel like writing all this. It's increasing where the slope's positive, from negative infinity to negative 2, and from 2 to infinity. Decreasing in the middle of those, negative 2 to 2. Concave up from 0 to infinity. Conc down from negative infinity to 0. Is that it? Increasing, decreasing intervals and graph it. Okay. Well, this one's pretty easy to graph. Let's draw it over here. Let's see, we know at 0 it changes concavity, so it's going to be down and then up. I mean, it's an x to the third graph, so that should tell you pretty much that it's going to look like that. Yeah, and then look at up, down, up. So let's see. Get my y-intercept 2, right? Plug in 0 for x, 0, 0, 2. It's a good place to start. And then you don't have to get real exact with this. You could plug in numbers to get other points, but I don't know. Maybe it's just because I'm tired, but it's going to be something like that. And like that. Good enough. I mean, yeah, if you wanted to, you could plug in points to figure out how far down to go, or, yeah, not worried about it right now. That's good. Second one. That So first derivative, you could either do quotient rule or change it to x squared times x plus 2 to the negative 1. Do product rule. It doesn't matter. I'll do quotient. Low, d high, so derivative of the top minus the top times the derivative of the bottom, all times the bottom squared. Or times over the bottom squared. So plus that, so you get x squared, let's see, 2x squared minus x squared would be x squared plus 4x over x plus 2 squared. Here's the first derivative. And then for second derivative, you can do quotient rule again. So the second derivative, low derivative of the top would be 2x plus 4 minus the top. Derivative of the bottom, say it would be 2 times x plus 2 to the first times the derivative of the inside, which would just be 1. Right, chain rule it. All over low d high minus high d low over low squared. Ew, that one got kind of ugly. So that would be x squared plus 4x plus 4 times 2x plus 4. Well, oh joy, x squared plus 4. This isn't nearly as bad as the number 2 one I originally gave you. So that stays on bottom. What's this? 2x plus 4 times. What's a distributive property action? Let's see. 2x to the third. We're running out of room. It'll be 2x to the third plus 8x squared plus 8x plus 4x squared. I like to write it down here. Plus 16x. But then I confuse myself with that. Yeah, plus 4x squared plus 16x plus 16 minus 2x to the third plus 8x squared plus 4x squared plus 16x, and this is all like minus all of that, so what's 2x to the third plus 12x squared plus 24x plus 16 minus 2x to the third minus, let's see, 12x squared, what? Minus 16x. It's going to be 8x plus 16. Cool. So there's the top. So finally, my second derivative is 8x plus 16 over x plus 4 to the fourth. Hopefully that's right. So now, answer all the questions. Let's see, first derivative, number line. Oh, we gotta get our extrema, so critical points where that equals 0, so x squared plus 4x equals 0, factor out an x plus 4, so x equals 0 and negative 4, where that doesn't exist, hey, where the bottom's 0, so negative 2, and then the original, let's see, any endpoints, well, negative 2, x can't be negative 2, so we already got that though. So there's all my critical points. Let's see, negative 4, -2, 0. So to the left on -5, let's see, plug in -5. See, the bottom's squared, so the bottom will always be positive. So we just got to worry about the sign of the top. If I plug in -5, squared is 25 minus 20. That's positive. Plug in -3. That'd be 9 minus 12. Negative. Plug in -1. Be 1 minus 4. Negative again. And then plug in like anything positive, and it's just going to be positive. So there's our sign chart for our slopes. Might as well do my second derivative one right now, just because it'll fit nicely right here. Let's see. Where that will equal 0 or not exist, let's see, 8x plus 16. Subtract 16 divided by 8, so that'll be -16 divided by 8, -2. And then the bottom can't be -4. So I got -4, -2. And I think that's it. Endpoints, same as, yeah, we're good. So plug in -5. Let's say the top is to the 4th power, so that'll always be positive. -5 would be -40 plus 16, that's negative. -3 would be -24 plus 16, that's negative. -1 would be -8 plus 16, that's positive. Okay, so now we can answer all the questions. I said you didn't have to graph this one. But, let's see. I figured all the questions. Local maxes and mins. So our derivative, up, down, down again, up. So no max or min here, remember that. So we got a local max at -4. And a local min at 0. Y values, let's see. -4, plugging in the original, it'll be 16 over -2, -8. What? That can't be right. -4 squared is 16, -4 minus plus 2 is -2. 16 over -2, wow, it's -8. Local min, plug in 0, it'd be 0 over 2, it'd be 0. That's weird that the max is lower than the min. But, okay, I'll draw it and then we'll see why that is. Let's see, what else? Increasing and decreasing. It's increasing from -infinity to -4 and from 0 to infinity. Decreasing from -4 to -2 and -2 to 0. And you can't just say -4 to 0 because the slope either hits 0 right here or doesn't exist right here. And looking back, if I plug in -2 to my derivative, the bottom's 0. So the slope doesn't exist right here, which means it's either a corner or a vertical spot, or maybe there's nothing there. But we'll look at that later. But it's not increasing or decreasing. What else do we need to answer? Oh, point of inflection. There's only one at -2. And we can get the y value for that because it's an actual point on the graph. Might as well get the y value. Put in -2, let's see, it'll be 4. Uh-oh, 4 over 0. You can't have that. So guess what? There is no point of inflection. That was good to check. Oops, I don't want to put a parenthesis. Because -2 is not in the domain of the original. So we're changing from concave down to concave up. But it's not in the domain of the original. I'll show you what that looks like in the graph. Let's keep going with the questions. Yeah, what else? Oh, concave up. Just set it from -2 to infinity, and concave down from -infinity to, well, it doesn't really change sign. So why do we get -4? I don't remember. Oh, because it didn't exist. Oh, there's a flat spot there. There's a, here, oh, okay, I see. So technically, yeah, I don't know. Let's go like this. So -infinity to -4 and -4 to -2. So there's all the questions if you wanted to know what it looks like when you graph it. Let's see, y-intercept, plug in 0 for x. Oh, it's 0. Right, 0 over 0. At -2, the original function doesn't exist. That's going to make that. You should remember, if the bottom's 0 in the original, that's where the vertical asymptotes are. So at -2, there's a vertical asymptote. At -4, we found we had a, where did we write it? A local max at -4, -8. So I'll call this -8. So -4, -8, that's a local max. That's weird. Well, positive slope to the right, negative slope to the, or positive slope to the left, negative slope to the right. So it's going to come up to that and then down. And that makes sense because it's concave down. So I got a negative slope and negative. This is weird. I don't even know how to do this. It's a positive slope to the, okay. So that's going to go like that. Okay. But then to the right of -4, we got a negative slope and it's still concave down until -2. Oh yeah, okay. So it's just gonna come down and follow that asymptote. Concave down the whole time from -4 to -2. Okay, that's just a flat spot. Something like that. And then after -2, we got a positive slope. There's a, oh, our local min at 0. 0, whoops, that's the wrong problem. 0, 0. Oh, hey, I already got that on there. So it's going to come down. Let's see, we're concave up. It's coming, okay, so it's going to go up along the asymptote. Like that. Come down, hit 0, then go back up. It's concave up the whole time. So something, I could plug in some more points. Like, if I plug in 1, that'd be 1/3. Okay, cool, so it's barely up. Plug in 2, that'd be 4, it'd be 1. It's just going to slowly come up. Something like that. I don't really see how accurate this was. I bet it's going to look a little more stretched out than this. So, x squared. Yeah, this is one of the, this calculator's different. I don't have my yellow one. The black ones show an asymptote with a line. None of your calculators do this, I don't think. But yeah, we got the picture. It was a little upside down parabola looking thing right there that's going to follow that asymptote. I guess that should be a little more back that, but I didn't plug in any numbers. And I didn't find my slant. We could have found slant asymptotes if we wanted to get hardcore about this. I don't know if you remember that from pre-calc, but because the power of the top is exactly one more than the power of the bottom. Does that sound familiar? Anyway, we could have found that, but whatever, no big deal. Close enough. That's it. Can't remember if I was going to say anything else. I don't think so.